Okay, so my name is Daniel. I work for MongoDB. I'm a solution architect for MongoDB, and I think most people, they kind of know MongoDB or have heard of it, but very few people know that's actually a company behind it. And we have, in fact, more than 5,000 employees worldwide, and let me see, 65 offices, yeah, and one in Zurich, in fact, like 200 meters from here. So the Zurich MongoDB headquarters is very close to the Deploy.io headquarters. And a lot of customers also. There's also a commercial offering behind it, an enterprise offering, a cloud-based offering. And I will talk a bit more about especially Atlas, our cloud-based offering. And as you know, or just as a reminder, MongoDB is a document-based database. That means we store information as structured documents. And the difference to a relational database, right, where you have even on a simple example of an address book, where you normalize the data, we put all of the information together. So it's much more intuitive. As you can see on the right-hand side, right, all of the information is together. It's also faster, because just to fetch one object, right, everything is together. We can just have one read operation, one write operation, and it's much more flexible because you can very easily make changes to it. We don't have a very fixed schema. You can just make changes as you go to the documents. Now, documents are universal. They don't have to be, just JSON objects in that sense. They can be tabular. We support GeoJSON support. You can do geo lookups on data. We have full text search support. So you just add a index on search. You can do autocomplete. You can do fuzzy search on data. We have native support for time series. So very efficient storage of time series data. Very efficient lookups also on time series data. And really combine everything that is, the strengths of relational, so ACID compliance on transactions, very complex ability to write complex queries, not just CRUD, but also what we call aggregations, multi-stage queries that can filter group data, lookup data, reference data, and combine that with everything that is NoSQL, right? The flexibility of what you know as NoSQL. Now, MongoDB is more than just the database. We have a cloud-based offering, as I mentioned, called Atlas, what we call the developer data platform. It's more than just the database itself. It's the integration into, let's say, object store on the cloud. So you can move data into object store, you can still query that. You can replicate across cloud. We're multi-cloud. We don't have our own data centers. So we run on the hyperscalers like AWS, Azure, and GCP. Not yet on Deploy.io, right, Tom? And also have a lot of additional options. We have also integrations into partner solutions for offline sync, and plenty of possibilities to make you productive. And depending on where you last remember using MongoDB, and that's a slide I like to show, we will not go through everything, right? We introduced Atlas in 2019, so a couple of years ago. Have quite some experience operating and running and offering MongoDB in the cloud. We introduced time series support, as I mentioned, tooling around migrating from relational to document. It's called Relational Migrator. And what I would like to focus on today, since it's a tech talk, a bit on vector search, on the Gen AI part that we recently added. And we'll dive into that now. Any questions so far? Otherwise, I will just dive into the next part, right? I'm sure you've all worked with, played with ChatGPT by now. I think it's nothing new anymore. And when I ask it, what are the top 3 songs this year, it knows the answer because it has been trained on information that is in the public internet, or is able to make the lookups to the internet, and is able to give me that answer. But when I slightly rephrase that question and say, okay, what are my favorite songs? it will not know the answer. And I have to give that information somehow to the model, right? So behind this are what we call foundational models or large language models when it's related to text. They are trained on a vast amount of data that is typically collected from the internet. So the information that they have access to is also from the internet. It's not from your personal space or whatever you, unless there's no password on your website. But yeah, so but the question then is, right, how do I add the personal stuff to the LLM? And yeah, so the question is, what kind of data should we give to these models? And what is then the relevant data that I can feed to that model so I can answer questions like, what are my top 3 songs? What is something that is relevant to me, right? My private information. And that leads us to a question of what is a vector? Because, well, let me first get into that, right? You know, all know vectors. Vectors are just sequences of numbers, can be any kind of dimension. Vectors can also capture some sort of meaning. And for example, a vector can represent a color. So these are 3 numbers in the RGB coordinate system. That's a color. So a sequence of 3 numbers can mean a certain color, a certain a hue, a certain intensity of color. It can also mean other things, right? So black is a 0, 0, 0, and so on. Now, a vector embedding then is a vector that captures some sort of meaning. So when I say I listen to Beyonce, that string, right, it has a certain meaning. The vector representation, as you all know, is just a sequence of numbers that is representing that particular meaning. Obviously, we don't really know. I'm just joking. We don't really know what these numbers mean. Usually, I can take, when I take some sort of unstructured information, some data, can be a text, can be maybe an image, can be anything, audio, for example. Depending on the encoder that I use, the foundation model, that encoder can take that unstructured information and output a vector that represents that meaning. And that makes it really easy. That's basically reducing the dimensions of the unstructured data that I have into something that is much more manageable. It's a vector of certain dimensions that capture that, right? When I try to plot this on a graph, you can see like a king and a queen are close by, right, on the coordinate system. Woman and man, they are on the opposite corner of that coordinate system. And the same then goes further. Any kind of artists or omelette and pizza is probably a food item, right? Mongo and Kafka, they're technology terms. Beyonce and Kylie, they are artists, musical artists. So this continues. If you put that information of the vector on some sort of graph, you see that the similar clusters will give you the same meanings. Huh? Now, knowing that, then, well, the question is, right, if these vectors then are really big, not just 2 dimensions, how do you deal with that if the vectors are bigger in length? And now, when we work with vector data from LLMs, this is where MongoDB can help, right? It can store vectors efficiently and find vectors efficiently for GenAI applications, and basically interacts with a framework that you have to work with that vector data and work with the foundation model to do the embeddings and also the generation of the answer. I can show you a demo, and some people have seen it before, and they have told me, like in a previous Tech Talk, someone tried it and it didn't work, or attempted to do it and it didn't work. So let's see, that's a challenge. Let me go here. like this, right? So let's see, I'll just reload very quickly. Okay, so is the prompt legible? It's a bit small, huh? Okay. Okay, so what I've done, I've basically taken the docs9ch website. You all know it, right? I've ingested all of the information from that website into MongoDB Atlas, embedded it as vectors, and I'll show you the data so you can have an understanding of how that looks like. And then I put it into a small chatbot, and then I can ask it questions like, what is deployo? And now it's the demo effect, right? Let's see if that works. Okay, it's a fully managed platform where you just bring your source code for your web application and take care of building and deploying it continuously. Is that correct? Yes. Okay. And it also gives you the links, so it works, right? It's better than the other guy. You gave me that challenge. But obviously this one is not very interesting, because if you go to docs9ch, you have full text search here, right? So deploy your, probably find the same information through full text search, because I can just go by the keyword. What's much more interesting if I ask it some more intelligent question, right? So I'm not sure, Tom, you mentioned something. What is the best hosting option for my web application? So the demo effect. What is the best hosting option for my web application? Ah. So it will actually go to the best hosting options for your web application depends on several factors. VPS, managed hosting. What deployer offers? Okay.
But if you go to the second resource, because it shows related yes. Oh, it's only read from that, and it came up from that.
Okay, but okay, can you give me a code example in C# for deployo? We tested C# is not supported, right? Oh, I made a typo. I'm sorry for any confusion, but deployo primarily supports languages like Ruby, PHP, Node.js. But then there's a Docker file beta support, right? So is that correct? Yeah, okay, yes. So that's actually...
For C# deployo.
Huh? Sorry?
Write support in C# for deployo.
So basically wanted to build the C#.
Ah, write it, code generated. That's a good one. Okay, so that's basically the output. Now the question, how does it actually get to that output, and how does the whole stack play together? Now I need to move that window here. So first of all, that's the config file of the. I'm going to show you a framework. It's just a sample framework that it's open source. You can download it, and it uses can integrate to different LLMs. Has different kind of sources, and one is the sitemap source. So I just indicated the docs9ch sitemap XML, and you can also give it PDFs and so on. And then you can indicate the LLMs. These are all cloud-based LLMs. Also Atlas, in this case, is cloud-based. And then the last question that I asked was, can you give me code example in C#, right? And let's try to dissect this a little bit. I hope. I'm struggling a bit to see it from the corner. Content. I mean, it's log output, so sorry, it's not really nicely formatted. Okay, and here's the last separator, right? I think, if I'm not mistaken. Okay, so from top to down, you can see there is a, that's the information that's sent to the LLM to generate the answer. Huh? So it starts with a prompt, and it says, you are a human-like chatbot, and receive some content. You will provide the answer to the question that the user asks. It's a system message. I think it's here, right? Role system. It's basically programming the LLM to do what it's supposed to do. And then it provides, with these wiggly lines, it provides the context. And as you can see, these are, well, it's not very nicely formatted, but you see these are chunks that come from the docs9ch website that contain the knowledge, the information to further program. That's the personal part that you inject right into the prompt. And that's what comes also from the database lookup, from the vector lookup. And essentially using all of this, and the rest is just debug information, I think. Can you give me code example? Me? Oh, I really service that in C#. And using this information, the LLM is able then to produce the answer that you have seen, right? The prompt and then the context. This architectural pattern of injecting context into an LLM prompt is called retrieval augmented generation, RAG. So it's the prompt, the context that you provide, and that's really where also then the vector search comes in, right? This prompt that I gave is put into a LLM. It's vectorized, and that vector is looked up in the database for similar stuff, as you have seen on the chart, and that content then injected into the prompt to generate the answer. That's essentially the flow. When you then look into the database, and is that legible? Can you see the documents on the right-hand side? These are the documents that are fetched from the ingestion. Basically, it goes through the sitemap, follows all of the URLs, and recursively follows the URLs, gets slices up the content into so-called chunks of size that you can configure, and then runs it through an embedding model. Basically, the embedding model is then providing the meaning of that data of the same chunk, and helps then also in the lookup, right? So when we're looking up by the vector. So the input prompt, vectorized, find similar vectors, return the chunks, insert the chunks into the prompt, and then generate the answer. So that's essentially the sequence. Questions? Or is that good? Cool. Yeah? Good. Any more questions that we can answer the LLM? Write C# so for deploy and deploy it, please. Not sure.
But it's not only looking at docs, right? Some other data inside.
So
what model does it have?
So on one hand, it's the model that has generic knowledge, right? Yeah. So if I ask it, I'm glad you're interested in deploy and C#. Does that? Is that correct? We could run it. So I think it gives you now the code for the Docker file. It's not natively supported, but it uses the Docker file support, right? And I haven't tried it. It uses NCTL. That's the command line, right?
Yeah, that doesn't work. If URL empty with error out.
We can go back to the fragments that it's found. Yes, so to get to your question, Dan, it takes the LLM's generic knowledge plus the context information and produces the output. So I can ask it, what are the OSI layers? What are the OSI layers? Let me see. So it's also trying to find it, and I think it's not on docs. And then, oh yeah, okay. standardize the functions of a communication system, and it's interesting. It did found.
Oh, that's a
Okay, so the resources are not 100%. That's probably DDoS here, right? DDoS protection and configuration layers. Okay, so let's just scroll like this. So it takes the URLs from the fragments that it thinks are similar. There is some threshold configuration that I can set. I set it to really be permissive. I can make it more less permissive, right? And then generate the answer out of that. Yeah.
So by setting it less permissive, you could basically force it to only answer from the docs.
I mean, like this, I probably get too many results. I need to increase the threshold, decrease the threshold, give it less content from docs. Yeah. Because obviously the answer that it generated was not from that pages, and it kind of gets confused on doing that. Yeah. So yeah, that's an option, right? It's different to the full text search that goes by tokens and words. It goes more by meaning. And okay, maybe well, what is the diff between NKE, managed hosting, and deploy? So these are 3 products, right? NKE, 9 Kubernetes, managed hosting. Not the wrong name. So let's see. Ideally, it finds the websites with these 3 products. It tries to compare them. So in summary, NKE is for deploying and managing containerized applications on Kubernetes, managed hosting for traditional server hosting, and deployer for deploying and managing web apps with ease. Is correct? Okay. Yeah. It's only as it's only as smart. Huh?
You're just a fire to save people.
Fire to. Okay, so it's only as smart as the context that you give it, right? And sometimes it doesn't get it 100% right. There's parameters that you can tune. But it's fun to experiment with that. And I had a lot of fun trying it out also for this talk. And to get to your question, Dan, what are the FMs used? I used, it's from AWS, like the Bedrock was, I think it was Titan for text embeddings, that's for the prompt. And then Mixtral for then the answer generation. And depending on the embedding model, you have different dimensions of the vectors. This one produces 1024. It's always 1024. So that also makes it easy on our end to generate the search indexes on the data. Like here, search index, right? I have a search index on the vector index field. It doesn't show the config, but in a certain dimension. So I can easily search for that. Okay, cool. When you want to try this out yourself, so I mentioned I used a framework. It's a framework that's provided by MongoDB. It's open source. You can download it from GitHub. You can configure it. Has all of the ingestions and the glue, and allows you to integrate with different LLMs, different sources, and it gives you this whole glue around building a chatbot, right? That's typically where a lot of people kind of start and find out. And it took me maybe 1 hour to get set up, and just getting to something that's working and kind of useful. Yeah. Cool. That was it. Thank you very much. And if you want to get in touch, I'm on LinkedIn and still here for beer afterwards. Yeah. Thanks.
Can I ask a quick question?
Yeah.
In this example, you ingested the whole website, right? And in the document store, one individual item was just a chunk
Yes.
of the website, right?
Yes.
So you can use RAG on this free text, right? But with we have Mongo with JSONs. You know, the individual document is just a JSON with some, I don't know, business meaning, something in it, some data. So would you use RAG on structured documents as well?
Do you have an attribute?
Now you're just doing it on kind of free text.
Yes, so here I ingested from an external source, chunked it up. If you already have data in MongoDB, you can say, okay, this is the field that I'm interested in, the text field.
Filter, like normal Mongo filter to make a query, where you say that this service would also somehow use LLM to create a good filter or a good Mongo query to look up in the structure.
You can, so if you have already a text field or something that you're interested in, you can run that through an LLM and generate a vector, and just put that vector in the same document and make it searchable, right? So you don't have to search from externally, if you know what I mean. So I can show you quick.
Somehow seems like defeating the purpose. Like if my document's already structured, I can search it very fast.
So search it how? Search it.
Write a query.
Yeah, but exactly the most important thing is how to write.
No, how?
Query. So
An exact.
Natural language to a query with some very cheap model maybe, but just to retrieve the useful document and then look up.
Okay, so you can have an exact query on an object by some attribute. Maybe it's a numerical attribute, or you can run a full text search, which runs by keyword, right? So these, I don't know, update, specified, these are keywords that are put into a search index. You can do that. Or you can go a different way and say, I want to have capture the meaning of what's in here. And then you need to run it through an embedding model and just add an embedding to your existing text. So there are different options depending on what you want to do. And you can also combine all of the approaches. You can do like a hybrid search and say, I want to search by text and meaning. Because it's very different to say, give me everything that contains deploy.io as a keyword versus what is the best hosting option. Do you see what I mean in terms of the query? So do you know what kind of query you're looking for your data?
Just in one case, we were building like some, also with LangChain, like some agent
Yeah.
that was supposed to search, like help customers to answer the question, I don't know, what kind of cars can I buy in this dealership? And then we have a bunch of documents from Ford, from Mazda, whatever, where they list thousands of models, and each of them, you know, is pre-configured with an individual JSON. And they say, I want a white Toyota 24 Toyota Yaris.
Yeah.
Can I buy it, you know? And I think this embedding was, in our use case, a bit of an overkill.
That's.
But this is maybe.
I see what you mean. It's maybe even a different use case.
Yeah.
So.
That's what I meant. Searching actual where a document is.
Yes. There's actually a field here called generate query, and it takes a natural language query and converts that to a MongoDB query. And that's a different approach altogether, right? It's like, give me all of the cars that have a sunroof, and then it will return a query based on that. That's yet another approach to work with data. So that's programming the LLM to write queries. Yeah, actually, some customers are doing that as well. That's quite interesting. It's a bit different approach altogether than here. Right? Yeah. Cool. I can show you some examples if you're interested. I have something afterwards, but yeah, okay, cool. Thanks a lot.